Now, sometimes it's, I've given you those rules, but sometimes it's okay to break the rules for one or two special structures. Particularly as Richard Harris is in the audience, I know you didn't work on this, but you work with lots of the engineers who worked on this. So this is the Mannheim gridshell. This is still the largest true timber shell which has ever been built. This was for the Mannheim Garden Festival in 1974. So this was Frei Otto at Stuttgart University, working with Ted Happold, who at that stage was running one of the building groups at Arup's in London. And of course, 1974 there was barely any computing power around. If you think it was only a couple of years after the Sydney Opera House. So Sydney was really the first building in the world to be designed with computers, so there weren't many computers around. So certainly not for an ordinary project like the Mannheim gridshell, so that really had to be designed by hand and with the help of these sort of hanging chain models. So obviously very much inspired, this is what Frei Otto was doing, very much inspired by Gaudi's work. And here you can see it's under construction. So this is incredible. This is a roughly 40 meter span roof. Those timbers that you're looking at, they are simply 50 by 50 millimeters in cross-section. So, your overall structural depth there, you can see is something like 200 meters. So you've got a span to depth on this roof of something like 1 to 200. So you've got two of these timber laths in each direction. So they're loosely bolted together. You can see that bolt is in a slotted hole. So that was laid out flat on the ground as a grillage. And then very, very slowly it was lifted up into shape. So that's what you can see, these sort of scaffold towers that were used to help slowly lift it. This is during the lifting. Now, obviously, once it's in the final shape, you need to hold it in that shape. So the bolts are tightened. I think there was some, if I recall correctly, Richard, you'll know this better than me, I think there were some spring washers just to take up the residual shrinkage of the still slightly green timber. I think some shear blocks went in to join the two layers of timber together to try and make them work compositely. And you can see this sort of cross bracing went in to sort of start holding it in shape. Of course, it's a shell, so a shell needs a tension ring. So the shell was made over length, and then the edge of it was clamped between a pair of glulam beams. And so there's the finished result. This, as I say, most structures in any material, you're looking at a span to depth of something like 20. But if you can create a shell type structure, you can get up to more like 200 rather than 20. So incredibly efficient, like an egg, really.